my dear students, let's start the session.
Simple harmonic motion. SHM. Simple harmonic motion. SHM. SHM. First write down. Linear SHM. Linear SHM. Definition of simple harmonic motion. Linear SHM. Linear SHM. If acceleration of the particle, write down. If linear acceleration of the particle. అసలు మైకే లేదేరా రాయట్లే రైటా if linear acceleration of the particle, linear acceleration of the particle, linear acceleration of the particle is directly proportional to linear acceleration of the particle, directly proportional to linear displacement of the particle, 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 then the particle is said to be in linear displacement of the particle, then the particle said to be in then the particle said to be in linear simple harmonic motion, linear simple harmonic motion. Here acceleration of the particle, linear acceleration of the particle directly proportional to displacement of the particle, then the particle is said to be in simple harmonic motion, that is proportionality minus omega n square x. Remove the proportionality, introduce the proportionality constant minus omega n x minus omega n square x. X is the linear displacement of the particle, linear displacement of the particle, linear displacement of the particle, linear displacement of the particle. What is the velocity of the particle? Rate of change of displacement is called velocity. dx by dt, you can write it as dx by dt can be written as x dot one time differentiation velocity of the particle, velocity of the particle. What is the acceleration of the particle? Rate of change of velocity of the particle, double derivative of the displacement of the particle, that is x double dot. X double dot is what? Acceleration of the particle, acceleration of the particle. Okay, so here we can confidently write acceleration of the particle is directly proportional to x double dot directly proportional to x double dot equals to minus omega n square x. If you take it to the left hand side, plus omega n square x equal to 0. This is the equation of motion for linear SHM. equation of motion for linear SHM, equation of motion for linear SHM, linear simple harmonic motion. Acceleration of the particle directly proportional to displacement of the particle, then the particle is said to be in simple harmonic motion. Write down case A. When the particle is moving from mean position to extreme position, amplitude is the maximum displacement of the particle. Amplitude of the particle is nothing but maximum displacement of the particle is termed as amplitude. Maximum displacement of the particle is termed as amplitude of the particle.
Sound the new sound.
అసలు ఇది మైక్గా పనిచేయట్లేదు.
The voice
నెక్స్ట్ రైట్ కేస్ ఏ. కానివ్వండి. Linear SHM, we are having two definitions. Linear SHM as well as angular SHM in the syllabus. Linear SHM and angular SHM. Linear SHM, linear spring in the oscillations. Angular SHM, simple pendulum. Angular SHM, simple pendulum. First we need to focus on the linear SHM. Right now.
Sir, side lines, sir.
Velocity of the particle and acceleration of the particle. Here, this is the equation of motion. Omega n, natural frequency, natural angular frequency. Omega n equal to 2 pi by t, 2 pi fn. You can discuss. Here, you can write omega n can be written as 2 pi by t. 1 by t is the frequency. 1 by t is the frequency. That equals to 2 pi fn. 2 pi fn. Next, case A. Right now, case A. Case A. Write down case A. Total two cases. Case A. So when sin will come, what is the definition of x equal to a sin omega t? What is the meaning of x equal to a cos omega t? The equation of the displacement of the particle is x equal to a sin omega t and x equal to a cos omega t gives simple harmonic motion. What is the meaning of x equal to a sin omega t and a cos omega t? Total two cases. Right now, case A, when the particle is moving from mean position to extreme position. When the particle is moving from mean position to extreme position. Mean position to extreme position. Mean position is displacement of the particle is 0. Mean position to extreme position. Mean position to extreme position. X equal to A. We are having two extreme positions. SHM in the sense particle is oscillating between two extreme position about a mean position. Okay na? So particle is oscillating between two extreme position about a mean position. That is the simple harmonic motion. Mean position to extreme position. If you write a phasor diagram, see this. This is the phasor diagram. Here it can represent the phase. Here we already explained in the alternating current ACs phasor diagrams. We can represent entire simple harmonic motion in the circuit. Clear? See this. Here it is what? Displacement of the particle is how much? X equals to 0. This is X equals to 0. We can call it as mean position. Mean position. This is what? Right extreme position. Right extreme position. This is the left extreme position. This is the mean position. Right extreme position. Particle starts from mean position, ends at mean position. Then it completes one cycle. Starts from mean position to extreme position. Particle is moving from where to where? As per the case 1. Particle is moving from where to where? Mean position to extreme position. It is starting from position going towards extreme position with angular velocity omega. Clear? After time t, the particle attains the position P. After time t, the particle attains. This is the position P. After time t seconds. After time t seconds. After time t seconds, particle attains the position P. So during this, what is the angle? What is the how much angle from here to here? How much? Theta. How much here? Theta. Particle starts from mean position. Okay na? Mean position to extreme position. Then we can draw perpendicular here. You can draw the perpendicular here. This is the perpendicular. This is the OMP. From triangle OMP, displacement of the particle along x direction. X is the displacement of the particle along x direction. This is the displacement. Maximum displacement of the particle is A. Maximum displacement of the particle is A. Angular velocity of the particle, which is in SHM, is nothing but rate of change of angular displacement is called angular velocity. Theta by t for small angles. Theta can be written as omega t. Theta can be written as omega t. Theta can be written as omega t. Take triangle. This is the triangle. Take triangle. From triangle. From triangle OMP. What is the sin theta from triangle OMP? Chapandi. Sin theta equals to how much? This is how much? X by A. X by A. Just now we discussed theta equals to how much? Omega t. Theta equals to omega t. Then sin omega t can be written as X by A. X equals to how much? X equals to how much? A sin omega t. X equal to A sin omega t. We need to check whether this equation will follow SHM or not. X equal to A sin omega t follows SHM or not. We need to check it once. So how to check this part? What is the X dot? What is the X dot? Tell me. Velocity of the particle. Velocity of the particle. Differentiate. What you will get? Tell me. Omega A into how much? Cos omega t. Omega A into how much? Cos omega t. Again, one more differentiation. X double dot can be written as minus omega square A into sin omega t. Sin omega t. A sin omega t. Confidently written as. This is written as x. Then x double dot can be written as minus omega square into how much? X. X double dot is confidently you can write directly proportional to x. It follows SHM. Follows simple harmonic motion. So if you take x equal to a sin omega t, the particle starts from where? Particle starts from where? Mean position. Particle starts from mean position. Particle starts from mean position. Particle starts from mean position. When the particle starts from mean position, what is the governing equation for displacement of the particle in linear SHM? X equals to a sin omega t. Because it follows SHM. Why it follows SHM? Acceleration of the particle directly proportional to displacement of the particle. Here the proportionality constant can be written as minus omega square. Clear? Understood this? Next slide out. Randy. Some faculties will explain like x double dot is directly proportional to minus x. That or this both are same. If it is minus x, proportionality constant is positive. If you take directly proportional to x, I will take proportionality constant is negative. Clear? This minus is very important. In the proportionality, we need to put minus. So finally, this is the governing equation. X double dot must be satisfied. Omega n square x equal to 0 must be satisfied. Here plus, here should be plus. This is what? Undamped oscillations. Undamped, free oscillations. Free undamped oscillations. Completed. When the particle is moving from mean position to extreme position, what is the displacement of the particle? X equal to a sin omega t. This part done. Zebella. ఇప్పుడు మనము completed. X equal to a sin omega t. అయిపోయిందా ఇది? అయిపోయిందా ఇది? ఇది రాసుకోలేదంగా? రాయండి. ఇది చాలా పెద్ద ఇది SHM ఆసిలేషన్ సిస్టమ్ ఆఫ్ పార్టికల్స్ మంచి సబ్జెక్టులు అవి త్వరగా రాయాలి మీరు. Focus here. What is the displacement of the particle? X equals to a sin omega t. A sin omega t. What is the velocity of the particle? This is the displacement of the particle. Velocity of the particle is what? Txp by dt. This is equal to how much? Xp dot. That equals to how much? Velocity of the particle equal to how much? చెప్పండి. omega a cos omega t. Omega a cos omega t. What is the velocity of the particle? Omega a into square root of 1 minus sin square omega t. Sin square omega t. Sin omega t can be written as velocity of the particle equal to how much? Omega a square root of 1 minus sin omega t can be written as sin omega t can be written as sin omega t can be written as this is how much x by a, so minus x square by a square, x square by a square. Velocity of the particle equal to how much? Omega a into square root of a square minus x square by a square. Okay na? A gets cancelled out. Then velocity of the particle equal to how much? Here you can write velocity of the particle can be written as omega a into square root of a square minus x particle square, displacement of the particle square. అర్థమైందా? సో ఇప్పుడు మనము here you can write అయిపోయిందా ఇది? So we can write v square equal to omega into square root of a square minus x square. V equal to how much? Omega into square root of a square minus x square. Clear? Completed. Next data here velocity of the particle equal to how much? Velocity of the particle equal to how much? Omega a into cos omega t. Omega a into cos omega t. One more time differentiation, what you will get? Acceleration of the particle. Rate of change of velocity of the particle. రాస్తే ఏమొస్తుంది? మైనస్ ఒమేగా స్క్వేర్ ఇంటూ sin omega t. Here you can write acceleration equal to how much? Minus omega square into x. V equals to how much? Now tell me. Now we can write completed. Avinda? Now సో దీని మొత్తాన్ని మనం ఎలా రాస్తామంటే ఇక్కడ ఇలా రాయండి. చూడండి ఇక్కడ x equals to a sin omega t. X equals to a sin omega t. దీన్ని ఎలా రాయొచ్చు చెప్పండి? x equals to x maximum into sin omega t. X maximum into sin omega t. This is what? Maximum displacement of the particle. Maximum displacement of the particle. Maximum displacement of the particle. So called amplitude. So velocity equals to how much? Omega a into cos omega t. So we can write it as v equal to how much? V maximum into cos omega t. So v maximum equal to how much? Omega a. Omega is the maximum velocity of the particle. Maximum velocity of the particle is how much? Omega a. Maximum velocity of the particle is how much? Omega a. See here, మనం ఇంకో విధంగా ఎలా రాయొచ్చు v ఈక్వల్ టు హౌ మచ్ ఒమేగా ఇంటూ స్క్వేర్ రూట్ ఆఫ్ 1 మైనస్ దిస్ ఈజ్ a స్క్వేర్ మైనస్ x స్క్వేర్. సో ఇక్కడ నీకు ఏమొస్తుంది చెప్పు ఒమేగా a ఇంటూ స్క్వేర్ రూట్ ఆఫ్ 1 మైనస్ x స్క్వేర్ బై a స్క్వేర్. This is how much v maximum omega a v equal to how much omega a into this is how much v maximum into how much square root of 1 minus x square by a square 1 minus x square by a square. This is the v maximum. Next tell me acceleration of the particle equal to how much minus omega square a into sin omega t. Clear? So దీని మొత్తాన్ని ఏం రాయొచ్చు చెప్పు ఈ పర్టికులర్ దీన్ని ఏం రాయొచ్చు omega square a is the a maximum. Okay na? Acceleration equal to how much minus a maximum into sin omega t. What is the maximum acceleration of the particle? Omega square a. So when the particle is in simple harmonic motion, maximum displacement of the particle is capital A. Maximum velocity of the particle is omega a. Maximum acceleration of the particle is omega square a. Clear or not? Next. This part completed. Entire discussion is related to what? Particle starts from mean position x equal to a sin omega t. Clear? So what is the velocity of the particle? X dot equal to how much? Omega a into cos omega t. Clear? So we can write it as completed. We can write it as omega a is nothing but v maximum into how much? We can write it as sin pi by 2 plus omega t. Sin pi by 2 plus omega t. So sin pi by 2 plus omega t. Are you clear or not? So దీన్ని ఎలా రాయొచ్చు చెప్పు completed. దీన్ని ఎలా రాయొచ్చు చెప్పు sin pi by 2 plus omega t. దీన్ని ఎలా రాయొచ్చు omega a or else v maximum sin omega t plus pi by 2. అర్థమవుతుందా? So now tell me what is the acceleration of the particle? X double dot equals to దీన్ని ఏం రాయొచ్చు minus omega square a into sin omega t. That equals to a maximum into minus sin. We can write it as pi plus omega t. Third quadrant, sign is negative. So this negative also should satisfy. Minus sin omega t, sin pi plus omega t. This is how much? Omega square a into sin omega t plus omega t plus pi. Omega t plus pi. What is the phase of the displacement of the particle which is in SHM? It is passing from origin, starts from main position. Clear? So what is the phase of the displacement of the particle? What is the phase of the displacement of the particle? Phase of the displacement of the particle is how much? What is the phase? Omega t is the phase. Phase means what? Sign of something. Total is called phase. Clear? What is the phase of the velocity of the particle? What is the phase of velocity of the particle? Omega t plus pi by 2. What is the phase of acceleration of the particle? Phase of acceleration of the particle. Omega t plus pi. Omega t plus pi. Phase means sign of something. In order to calculate the phase difference, both must be written in the same function. Clear? Now tell me, what is the phase difference between statement number 1? Put a note. Statement number 1. The phase difference between just phase difference between velocity and displacement of the particle. Velocity and displacement of the particle. Displacement of the particle. What is the phase difference between velocity and displacement of the particle? What is the phase difference? Delta phi between velocity and displacement. That is what? Phase of. This is the phase of velocity minus phase of the displacement. Phase of the velocity and phase of the displacement. That is equal to how much? Pi by 2. That is equal to how much? Pi by 2. Just substitute omega t plus pi by 2 minus omega t. Next, not to 2. Not to 2. What is the phase difference between? What is the phase difference between? Phase difference between acceleration and displacement of the particle. Acceleration and displacement of the particle. Phase difference between acceleration and displacement. Acceleration and displacement. Phase of acceleration minus phase of the displacement. That equals to how much? That equals to how much? Omega t plus pi. Omega t plus pi minus omega t. Omega t. Then we can write it as pi. This is pi. Phase difference between acceleration and velocity of the particle. Completed. Not 3. Right now, phase difference between velocity and displacement of the particle. Acceleration and velocity of the particle. Acceleration and velocity of the particle. Acceleration and velocity of the particle. Velocity of the particle. Acceleration and velocity acceleration and velocity. This is how much? Pi minus pi by 2. That is pi by 2. Clear? Next write down.
Sir, wait, sir. Assignment.
Next write down. Velocity versus displacement graph. Velocity versus displacement graph. Completed. Completed. Next item. Entire discussion is related to what? Particle moves from mean position to extreme position. Right down. మనము velocity versus displacement గ్రాఫ్ రాయేసారా? రాయేసారా? ఏంటి? ఎట్టైనా ఒకటే ఉంటది. రైట్ డౌన్. సీరియస్.
ఇప్పుడే సార్ సైడ్ ఎడిటింగ్.
ఫోకస్ హియర్. ఫస్ట్ మనము మొత్తం రాయండి ఇక్కడ. ఫస్ట్ ఇది ఎక్స్పీరియన్స్ అవ్వండి. See this. This is the mean position. This is the mean position. Right extreme position. This is the left extreme position. Left extreme position. This is the mean position. Mean position. SHM అంటే ఎలా ఉంటుంది చెప్పు. ఫస్ట్ particle starts from mean position. It is moving like this. అర్థమవుతుందా? See this. This is the right extreme position. Right extreme position. Right extreme position. After that, it comes to mean position. It comes to mean position. Then go to the left extreme position. Go to the left extreme position. From left extreme position, this is right extreme position. Okay. Then it will come to mean position. But then one cycle will be completed. ఇది ఇట్లా వచ్చి ఇది ఇట్లా పోయి మళ్ళా ఇక్కడికి వస్తుంది. These all are what? Mean positions. X equal to 0. X equal to 0. Right extreme position. Right extreme position. X equal to plus A. X equal to plus A. X equal to minus A. Minus A. Distance measured along this direction. Positive. Positive. Along this direction. Negative. Negative. Clear? So here, this is x equal to plus A sin omega t. Particle starts from mean position and going towards right. Clear? So if it is moving towards left, x equal to minus A sin omega t. Minus A sin omega t. two equations. This is the single equation, two cases. X equal to minus a sin omega t means particle starts from mean position going towards left extreme position first. అర్థమవుతుందా? అర్థమవుతుందా? ఇది పాజిటివ్ అంటే ఇట్ ఈస్ మూవింగ్ టువార్డ్స్ రైట్ ఎక్స్ట్రీమ్ పొజిషన్. x equal to plus a sin omega t, x equal to minus a sin omega t. At t equal to 0, this is x equal to 0, this is t equal to 0, t equal to 0. అర్థమవుతుందా? సో ఇక్కడ it completes one amplitude here, one amplitude here, one amplitude here, one amplitude here. Clear? అర్థమవుతుందా? Particle starts from mean position to extreme position. How many amplitudes it can complete? Total 4. So how much time it will take to cover 1/4 of the cycle? T by 4. This is how much? T by 4. This is how much? T by 4. T by 4. This is how much? T by 4. Total how much time it will take? 1t.
Yes, sir.
One time period to complete one cycle. To complete one cycle. అర్థమైందా? This is the amplitude. This is the amplitude. This is the amplitude. Amplitude from here to here. So ఇప్పుడు mean position to right extreme position t by 4. Here this is how much? T by 4. From here to here how much? T by 4. T by 4. T by 4. So ఇక్కడ ఏంది? Mean position to right extreme position. Mean position to right extreme position. తర్వాత right extreme position to mean position. Left line. తర్వాత mean position to left extreme position. మళ్ళా left extreme position to mean position. అర్థమవుతుందా? What is time t here? What is the time t here? This is the particle. What is the time t here? This is theta. This is theta. What is the time t? Definition of time t here. X equal to plus a sin omega t లో t అంటే ఏం చెప్పండి? a sin omega t లో t అంటే ఏందో చెప్పండి? t అంటే ఏంది? Time taken by the particle to reach point P after passing mean position. Time taken by the particle. Time taken by the particle. Time taken by the particle to reach point P. Point P after passing mean position. After passing mean position. Time taken by the particle to reach point P after passing mean position. So mean position to right extreme position. Time period t by 4. But how much time it will take to reach extreme position after passing mean position? T by 4. Time taken to reach the mean position after passing right extreme position t by 4. అర్థమైందా? At mean position. This is how much? Left extreme position anta. See this. Okay. At this is x equal to 0. X equal to how much? Minus a. What is the velocity of the particle at mean position? Velocity of the particle equal to how much? Omega a into square root of 1 minus x square by a square. X square by a square. Put x equal to 0. X equal to 0 we need to put. X equal to 0. X equal to 0. పెడితే ఏమొస్తుంది? Velocity would be maximum at mean position. Velocity is maximum at mean position at right extreme position. What is the acceleration? Minus omega square x. Acceleration is what? Minus omega square x. Okay, now acceleration is maximum at. Acceleration is maximum. This is minus omega square a. What is the acceleration maximum at extreme position? This is plus omega square a. Put x equal to minus a at left extreme position. Put x equal to plus a at right extreme position. Clear or not? Put x equal to plus a, minus omega square a will come. Put x equal to minus a, plus omega square will come. What is the acceleration of the particle at right and left extreme positions? Maximum. Velocity will be maximum at mean position. Velocity will be maximum at mean position. What about acceleration? Acceleration is minimum. That is how much? Minus omega square into x. X should be how much? 0 at mean position. 0 at mean position. Acceleration is minimum. That is 0 at mean position. Velocity would be minimum. Velocity would be minimum. That equal to how much? Omega a into square root of 1 minus x square by a square. Put x equal to plus a. Then what is obtained here? Put x equal to plus a. X equal to plus a. Velocity would be minimum. Velocity would be minimum. That equals to 0. Velocity would be minimum. That equals to 0. This is at right hand. This is left and right extreme positions. Yet left extreme position. Left extreme position. Yet left extreme position. Yet left extreme position. This is at. This is at. Yet mean position. Yet mean position. This is at right extreme position. Right extreme position. Right. Right extreme position. Right extreme position. At the right extreme position, you will be getting velocity would be minimum and acceleration would be maximum, but it should be what? Negative. Negative. At left extreme position, acceleration is maximum, but it is positive. Velocity would be maximum at mean position. So wherever it starts, it doesn't matter. This is the basic definition of simple harmonic motion. In entire SHM, velocity must be maximum at mean position. Acceleration should be 0. This is the basic fundamental knowledge related to simple harmonic motion. Now write down graphs in SHM. Graphs in SHM.